Welcome to techaily.ai and welcome to the deep dive. Today, we're really aiming to cut through the noise. We're diving into two areas that are just exploding right now in tech. It's cloud compliance and something really fascinating, the real-world deployment of advanced AI within the enterprise.
Yeah, these are critical topics.
Absolutely. Our mission, like always, is to give you the essential knowledge. We want you to feel equipped, to navigate this complex landscape of data security and, well, cutting-edge innovation.
And there are some surprising facts, definitely some practical takeaways waiting for you.
Before we dive in, though, I want to mention that this deep dive is proudly sponsored by Stonefly. Stonefly is your trusted solution provider and advisor. They cover enterprise storage, backup disaster recovery, hyperconverged solutions for VMware, Hyper-V, Proxmox clusters, AI servers, SA365, which is a turnkey security appliance, and of course, public and private cloud solutions.
A really comprehensive offering for enterprise needs.
Exactly. You can find out more about how Stonefly can support your business at stonefly.com. Okay, let's jump in. Let's start with something that feels, well, pretty much unavoidable today. The cloud. It seems like every single organization, big or small, is moving more and more stuff there.
It really does. And, that shift, it comes with a whole new set of risks that maybe aren't always fully appreciated.
Right. So what's the reality on the ground? How much are we actually talking about?
Well, the stats really paint a picture. As of today, something like 60% of all corporate data is sitting in the cloud. That's huge.
60%. Wow.
And maybe even more telling, nearly half of businesses, 48%, they're trusting their most critical, their most important data to the cloud. This isn't, just a trend. It's fundamental now.
Okay, that's a massive amount of really crucial information out there. The benefits, scalability, agility, we hear about those all the time. But what about the security side? Are we seeing problems scale up too?
We are indeed. The security implications are pretty stark, actually. Recent data shows a worrying 80% of companies have experienced a cloud security breach. 80%.
That's incredibly high.
It is. And it's not just the number of incidents, it's the scale of the vulnerability that's growing. There's been almost a 600% annual growth in what we call the vulnerable cloud attack surface.
So basically, many more doors left open for attackers.
Exactly. More potential entry points. And compounding that, we've seen nearly a 590% increase in unresolved security vulnerabilities, things that are known but not fixed.
That sounds like a ticking time bomb for a lot of places.
It really does. And the cost when things go wrong, it's significant. Breaches involving cloud data, they tend to be much more expensive than, say, on-premise ones.
How much more?
We're talking averages like USD 4.75 million for breaches that span multiple environments, and even just public cloud breaches average around USD 4.57 million.
That's serious money.
Absolutely. And it's not just fines, which can be huge themselves. It's the reputational damage, losing customer trust, the operational chaos. It can genuinely cripple a business. So yeah, getting a handle on cloud security and compliance, it's not just nice to have, it's essential for survival.
Okay, that definitely drives home the urgency. We hear the term cloud compliance a lot, but let's unpack this. What exactly is cloud compliance? Can you break it down for us?
Sure. At its core, cloud compliance is really the process, the system, for sticking to all the rules that govern how organizations use cloud services. And it's not just vague guidelines. We're talking strict regulatory standards, local laws, national laws, even international laws. Think of it like a multi-layered rulebook for the cloud.
Okay, layers. What kind of layers are we talking about?
Well, you've got industry-specific standards like PCI DSS, that's the payment card industry data security standard, absolutely crucial if you handle credit cards.
Right.
Then there's HIPAA, the Health Insurance Portability and Accountability Act, vital for healthcare, obviously. Beyond those specific industries, you have broader laws. The big one is GDPR, the EU's General Data Protection Regulation, which has, a massive global impact. And then finally, you have the company's own internal rules, their governance policies. These are the guidelines they set for themselves to meet their own business goals, how they organize data, track it, who owns what in their cloud strategy.
Okay, so if I'm hearing you right, compliance is the external stuff laws. Industry rules you have to follow. Governance is more the internal rulebook for how the company wants to operate.
That's a great way to put it. Compliance is often externally mandated. Governance is internal.
But isn't there a risk there? Like, could a company's internal governance be, well, not strict enough to actually meet those external compliance rules? How do you make sure they line up?
That's a critical point, and yeah, it's a common trap. While compliance is driven by outside forces and governance is internal, they absolutely have to be aligned. Good governance isn't just, ticking boxes internally. It should actively set the stage for how the company achieves and maintains compliance.
So governance enables compliance, ideally.
Exactly. If your internal policies aren't robust enough to cover, say, GDPR's requirements, you're building on shaky ground. You need that alignment. It means constant internal checks, understanding the regulations, making sure internal goals support external rules. They're two sides of the same coin, really.
That makes sense. But even with clear definitions, the cloud landscape itself feels complicated, especially when companies use multiple providers. What are some of the big operational hurdles folks face trying to stay compliant?
Oh, complexity is a huge one, especially with multi-cloud. The data shows that, 79% of companies use more than one cloud provider. The average is actually 2.3 providers per company.
2 or 3 different cloud environments to manage.
Precisely. And that immediately expands your attack surface. More entry points, more complexity in managing security. Each provider, AWS, Azure, Google Cloud, whoever they, have their own tools, their own configurations, their own way of handling shared responsibility.
So just managing that inconsistency must be a nightmare.
It's a massive undertaking. You might need separate teams, or you need to heavily invest in training your existing teams just to handle the nuances of each platform.
And I've heard terms like shadow IT and shadow data. How do they make things even worse? Sounds like trouble.
They're absolutely a recipe for disaster. Shadow IT, that's when employees use cloud services or tech without getting the okay from the IT department.
Like using their personal Dropbox for work files?
Exactly. Or signing up for some sauce tool for collaboration without running it through the proper channels. It seems harmless, maybe, but the danger is huge. These unapproved services, they often lack proper security configurations, oversight.
So gaping security holes.
Gaping holes. Lost data potential, expanding the attack surface in ways IT doesn't even know about, and boom, noncompliance. With internal policies, with external regulations, it's a direct path to problems.
Okay, and shadow data, is that related?
Very related. Shadow data is sensitive information stored in the cloud, but the organization isn't actively tracking or managing it. Think about it. How do you secure something you can't even see?
Right, you can't protect what you don't know exists.
Exactly. With cloud apps being adopted so quickly, it's alarmingly easy for sensitive stuff. Customer lists, financial data, designs to end up in untracked corners, especially across multiple clouds. If you don't know where your sensitive data is, you can't protect it properly, you can't ensure it meets GDPR or HIPAA rules. Huge blind spots. Instant red flags for auditors and attackers.
Huge blind spots indeed. Which brings up another point. This idea of relying too heavily on the cloud provider's security. It's easy to think, hey, I'm with AWS, they've got this handled, right?
It is easy to think that, and it's an incredibly dangerous assumption. It leads to major compliance gaps. So many organizations have this false sense of security. They see the CSP's long list of certifications, their impressive infrastructure, and think, my data's safe.
But it's not always the case.
Not always. The reality is, even the biggest, most reputable providers can have vulnerabilities. Remember the Azure Cosmos DB issue back in 2021?
Vaguely, yeah. What happened there?
It was a pretty significant flaw in a database service used by major companies. And it went undetected for 2 years. It allowed potential theft of access keys.
2 years undetected.
Wow.
Yeah.
It's a stark reminder that customer vigilance, your own proactive security management, is absolutely paramount. The CSP secures the underlying infrastructure, sure, but the ultimate responsibility for your data, your configurations, that always rests with you, the customer. Governance accountability. You can't outsource that. It's a critical distinction.
A very critical distinction. Okay, let's pivot then to some specific global compliance frameworks. You mentioned GDPR earlier, the General Data Protection Regulation. You said it was designed with cloud in mind, which is interesting.
It is. GDPR, which came into effect in 2018, is an EU regulation, but it was really built for the digital cloud-first era. Its main goal is to regulate how businesses handle personal data, and it defines that term very broadly in Article 4.
How broad are we talking?
Very broad. It's any information relating to an identified or identifiable person. So not just the obvious stuff like a name or ID number. It includes location data, online identifiers like IP addresses or cookie IDs, and even factors about someone's physical, genetic, mental, economic, cultural, or social identity.
So pretty much anything that could potentially link back to a specific person.
Exactly. It casts a wide net to ensure privacy is protected proactively.
When its reach is huge too, right? It's not just for EU companies.
That's a crucial point, and yeah, it catches a lot of businesses off guard. It applies to any organization anywhere in the world that collects or processes the personal data of EU residents.
So a U.S. company with EU customers is covered.
Absolutely. Even if you have no physical presence in the EU, if EU residents use your website or app, GDPR applies to you. And importantly, unlike some other rules, GDPR doesn't give small organizations a pass on the core requirements. The fundamental principles apply to everyone.
Okay, so what are these fundamental principles? What does GDPR actually demand?
Article 5 lays out 7 key principles. It's really about a shift towards radical data stewardship. First is lawfulness, fairness, and transparency. You need to be open, clear, legally sound in how you use data. It's about rethinking the data's journey, making sure it's transparent. Second, purpose limitation. Only collect data for specific, legitimate reasons. Don't just hoard it.
Makes sense.
Third, data minimization. Only collect what's absolutely necessary for that purpose. Fourth, accuracy. Keep data correct, let people fix errors. Fifth, storage limitation. Don't keep data forever if you don't need it. Sixth, integrity and confidentiality, which means security. Implement reasonable measures to protect the data. And finally, seventh, accountability. You have to be able to prove you're following these principles. It's about being proactive, not just reactive.
That sounds like a significant shift in mindset for many businesses. A lot to manage. So what happens if you don't comply? What are the real consequences?
The consequences are substantial. The fines can be really steep, up to 20 million euros or 4% of your annual global revenue, whichever is higher.
4% of global revenue. That could be huge.
Massive. And it's assessed per infringement, so you could get hit multiple times for different violations found in one audit. We've seen big fines already. Amazon got hit with one for, what was it, 636 million? These aren't minor penalties. They can have a profound impact.
Okay, switching gears a bit, let's talk about HIPAA, Health Insurance Portability and Accountability Act from '96, and then ATEC came later. Crucial for healthcare, but how does it interact with the cloud, especially given HIPAA's age?
Right. HIPAA and HITECH are the bedrock for protecting health info in the U.S. HITECH in 2009 really beefed up enforcement and addressed newer technologies. A key thing to understand is the difference between PII and PHI.
Okay, PII versus PHI.
PII. Personally identifiable information is pretty broad. Anything that identifies someone. Name, social security number, etc. PHI protected health information is much more specific. It's a list of 18 identifiers.
18 specific things, like what?
Things like names, detailed addresses, all kinds of dates related to a person: birth, death, admission, discharge phone numbers, email, SSNs, medical record numbers, health plan numbers, account numbers, license numbers, device IDs, URLs, IP addresses, biometrics, full face photos, basically anything from that list when it's linked to health information.
Got it. So if data is de-identified, stripped of those 18 things, it's not PHI anymore.
Correct. De-identified data isn't considered PHI under HIPAA.
So who exactly has to follow these rules when cloud is involved in healthcare?
Primarily 2 groups. First, covered entities. These are health plans, healthcare clearinghouses, and providers who handle electronic health info. Second, and this is key for cloud, business associates. These are entities that perform functions for a covered entity involving access to PHI. So if a cloud service provider stores, transmits, or processes PHI for a hospital, for example, they are a business associate. They must comply with HIPAA.
So the responsibility is shared between the healthcare provider and their cloud partner.
Absolutely. Both are on the hook.
And what if there's a breach involving PHI? What are the rules there? How does the cloud provider fit in?
The HIPAA breach notification rule is very strict, and it directly involves CSPs as business associates. Both covered entities and business associates have to notify if there's a breach of PHI. A breach is basically an unauthorized use or disclosure that compromises PHI security or privacy. You have to assess things like what data was involved, who got unauthorized access, was it actually viewed, what mitigation was done. If a breach affects over 500 people, the covered entity has to tell the Secretary of Health and Human Services within 60 days.
And the CSP's role in that?
CSPs, as business associates, are directly liable for HIPAA violations themselves. Things like failing to provide records, not notifying the covered entity about a breach, using PHI improperly, not providing copies of PHI when required, or failing to have agreements with their own subcontractors who might handle PHI.
Okay, that sounds like it requires a really strong contract between the healthcare provider and the cloud provider.
Exactly. That brings us to the Business Associate Agreement, or BAA. This is mandatory. It's a written contract that spells out exactly what the business associate can and can't do with PHI, the safeguards they must use, reporting requirements, everything.
No BAA, no handling PHI.
Pretty much. Without a BAA, both parties are facing heavy fines. It's not just paperwork. It's the absolute foundation of HIPAA compliance in the cloud.
Can you give us a practical example? How might a CSP actually build their service to meet these HIPAA needs and back up that BAA?
Sure. Let's look at CouchDrop, which specializes in secure file transfers. They show a good understanding of this. First off, crucially, they don't actually store customer data themselves. They integrate with storage you already have, so you control where the PHI physically resides.
So the customer keeps control of the storage location.
Right. And for processing HIPAA data, they use dedicated compute nodes only in the U.S., specifically San Francisco. This ensures the data processing stays domestic, which is often preferred for PHI. And these nodes are within AWS's HIPAA compliant clusters, which also meet other relevant standards like FedRAMP and NIST 853.
Okay, so infrastructure and location are addressed. What about security measures?
They employ strong encryption, AES 256 for data at rest. For data in transit, it's HTTPS with at least TLS 1.2 or SSH, plus options for RSA 2048-bit keys. They also maintain SOC2 compliance, have granular access controls, things like locking down transfers to specific IPs or protocols per user, and provide detailed access logs. All these measures help demonstrate the appropriate safeguards required by HIPAA and the BAA.
That's a solid multi-layered approach. Okay, let's shift to another big one. ISO 27001. It's an international standard, but it's voluntary, right? How does it fit into cloud security?
Right. ISO 27001 is the International Standard for Information Security Management Systems, or ISMS. It's a comprehensive framework, really, over 100 security controls across 14 categories.
Like what kind of categories?
Things like information security policies, how security is organized, asset management, access control, cryptography, physical security, operations security, incident management, compliance. It's pretty broad. The goal is a systematic, best practice approach to keeping sensitive company info secure, available, and confidential.
But if it's voluntary, why do companies bother? No legal mandate like GDPR or HIPAA means no fines, right? So what's the motivation?
That's a key point. No direct legal penalties for not having ISO 27001. But companies pursue it for very strong strategic reasons. First, it's a powerful signal of commitment to security.
Like a badge of honor.
Sort of, but more practical. It helps prove to partners, customers, stakeholders that you have effective, internationally recognized security controls in place. It builds trust, which is huge. It can even be a requirement for winning certain contracts.
Okay, trust and market access. What else?
Second, it's a proactive risk discovery tool. Going through the rigorous ISO 27001 audit process forces you to find security gaps or vulnerabilities before they cause a breach that could lead to fines under GDPR or HIPAA.
So it helps you get your house in order to meet those other mandatory requirements.
Exactly. It's like a comprehensive health check for your security posture. You find and fix problems proactively, reducing the risk of those big regulatory fines down the road.
Are there other ISO standards that work with 27001, especially for cloud?
Yes, definitely. ISO 27001 is the main ISMS standard. Then you have ISO 27007. That's a code of practice with additional security controls specifically for cloud services. It builds on ISO 27002 but tailors it for the cloud. And there's ISO 27018, which is even more specific. It focuses on protecting personally identifiable information, PII, in public clouds. Companies often go for these alongside 27001 certification for more robust cloud assurance.
So how do these ISO controls translate into practice for cloud environments? Even thinking about things like containers, what are the general best practices?
Implementing ISO 27001 in the cloud involves several key practices. First, choose an ISO 27001 compliant cloud vendor. Doesn't mean you're compliant, but it means the foundation is solid.
Right, shared responsibility again.
Exactly. Second, use cloud auditing and compliance tools, native CSP tools or third-party ones. They scan your setup, find misconfigurations, help you assess compliance automatically. Third, master cloud IAM identity and access management. This is fundamental for controlling who accesses what, applying least privilege. You need to audit these configurations regularly too.
Access control is always critical.
Always. Fourth, encrypt sensitive data, both at rest and in transit. Configure default encryption on storage. Use TLS for network traffic, core requirement. Fifth, implement network isolation. Use things like virtual private clouds, VPCs, to segment your network and enforce access rules.
Okay, and for containers like Kubernetes, anything specific there?
Yes, containers need special attention. Container image scanning is vital. Scan images for malware or known vulnerabilities before you deploy them. That hits operational security controls. Audit logging is crucial too, especially Kubernetes audit logs. You need that trail to detect issues and prove accountability. And finally, container-specific access control. Augment your cloud IAM with tools like Kubernetes RBAC, role-based access control, and security contexts. This gives you granular control over what can run inside your containers.
Beyond the big three GDPR, IPA, ISO, what other frameworks should people know about for cloud security? Seems like a complex web depending on your business.
It can be. There are several others worth mentioning. PCI DSS, we touched on it, mandatory if you handle payment cards. Then SOC2, System and Organization Controls 2. This is voluntary, like ISO 27001, but widely requested by business partners. It demonstrates controls around security, availability, processing integrity, confidentiality, and privacy.
Okay. What about government-related ones?
In the U.S., you have the NIST frameworks, like NIST 853, which is a huge catalog of security and privacy controls, often used by federal agencies, and FedRAMP, which specifically governs cloud services used by the U.S. federal government. And one more general one is the CSA Cloud Controls Matrix, CCM, from the Cloud Security Alliance. It's a detailed framework mapping controls to various standards, helping define a baseline for cloud security. The key is identifying which of these apply to your specific industry, data types, and where you operate.
Okay, here's where it gets really interesting for me. We talk about all these controls, but in the cloud, who is actually responsible for what? This shared responsibility model concept seems absolutely critical.
It is arguably one of the most critical concepts, and yeah, it's often misunderstood. It basically draws the line between what the cloud service provider, CSP, is responsible for and what you, the cloud service consumer, CSC, are responsible for. Knowing where that line is crucial.
So it's not just the cloud provider handles security.
Definitely not. And the line moves depending on the service model you use. Let's take infrastructure as a service. Think of it like renting land and basic utilities. The CSP secures the physical stuff, the data centers, servers, networking, the virtualization layer.
And the foundation.
Right. But you, the customer, are responsible for pretty much everything you build on top. The operating system, any applications, your configurations, your data, network traffic controls within your virtual network, that's all on you.
Right. So more control, but more responsibility. What about PaaS?
Platform as a service? PaaS. Here, the CSP takes on more. They manage the underlying platform, the OS, middleware, runtime environments, but you're still responsible for your applications, the data they use, and how you configure the security of that platform and your apps.
Okay, a bit less for the customer to manage. In SaaS?
Software as a service. This is where the CSP handles the most. They manage the application itself, the platform, the infrastructure. Your responsibility is usually focused on managing users within that application, who gets access, what permissions they have, authorization, entitlements.
So if I'm using a SaaS product, maybe like Salesforce or Office 365, can I just wash my hands of compliance worries then? Or is that still falling into that dangerous assumption trap?
Still a dangerous assumption. This is the core truth. Even with SaaS, where the provider does the most, the ultimate responsibility for compliance regarding your data and your configurations always lies with you, the customer.
You can't outsource accountability.
Exactly. Governance accountability cannot be outsourced. If your data gets breached because you set up weak access controls in that SaaS app, the legal fallout, the reputational hit, that lands on you. You have to know where that line is drawn and own your part.
That really clarifies the shared model. It brings up another interesting question, though. Data location. Does where the server physically sits actually matter under GDPR? I feel like I hear conflicting advice all the time.
Yeah, that's a really common point of confusion. The short answer is data localization, meaning forcing data to be stored within a specific country or region, is not a strict legal requirement of GDPR itself.
Oh, interesting. So the focus isn't just keep it in Europe.
Not solely, no. GDPR's primary focus is on ensuring robust data protection practices wherever the data happens to be. It's more about how you protect the data than precisely where it sits.
But there must be rules about sending data outside Europe, right?
Absolutely. That's the crucial part. GDPR mandates appropriate safeguards if you transfer personal data outside the EU or the European Economic Area, EEA. These safeguards are key. They can include things like adequacy decisions. That's when the European Commission formally decides a non-EU country provides an adequate level of protection. Switzerland and the UK currently have these, for example.
Okay, adequacy.
Yeah.
What else?
Then you have standard contractual clauses, or SCCs. These are pre-approved legal clauses you put into contracts to ensure data protection when transferring data. And binding corporate rules, or BCRs, which are internal rules big multinational companies can adopt for transfers within their own group, binding all their EU entities.
Right. And didn't that Schrems II court case shake things up regarding transfers to the U.S.?
Oh, massively. Schrems II, back in 2020, invalidated the old EU-US Privacy Shield framework. The court basically said U.S. surveillance laws didn't offer adequate protection for EU citizens' data privacy rights under GDPR.
It's making transfers to the U.S. much harder.
Much more complicated, yes. It definitely led to more companies choosing to localize data within Europe if possible, just to avoid the complexities and perceived risks of transferring data to the U.S. under the stricter post-Schrems II requirements. But here's the crucial takeaway, the nuance. While localization can simplify things, the ultimate focus must remain on implementing strong, consistent data protection practices. Encryption like TLS, robust encryption at rest, solid third-party management. These things matter regardless of physical location.
So security practices trump geography, fundamentally.
Fundamentally, yes. Though the global trend is towards stricter localization laws in many places. China, Russia, India have tough rules. But even then, solid security practices are the bedrock.
That's a really important clarification. Okay, so pulling all this together for our listeners who want to get cloud compliance right, what are the absolute best practices they should be implementing?
Okay, yeah, let's distill it down. Given all the complexity, having a clear roadmap is vital. I think we can break it down into 11 key practices, maybe grouping them into, say, foundational knowledge, proactive security, and operational excellence.
Sounds good. Let's start with foundational knowledge.
All right, 1. Identify regulations and guidelines. You absolutely have to know which rules apply to you. ISO 27001, PCI, DSS, HIPAA, SOC2, NIST, FedRAMP, GDPR. Know your specific landscape. 2. Understand responsibility. Get crystal clear on that shared responsibility model with your CSP. Know exactly where their job ends and yours begins. Remember, compliance for your data, your configs, that's on you. 3. Understand unique environment requirements. Recognize that IS-PAPA, SAPA, SASA, hybrid, public-private, they all have different security needs and risks. Tailor your approach accordingly.
Okay, foundation's laid. What about being proactive with security?
Right. 4. Ensure proper access control. This is huge. Implement least privilege. Access should be need-based. Set expiration dates. Control who gets in and what they can do. Keep unnecessary trashing out. 5. Classify your data. Know what data you have, sort it by sensitivity. This helps you protect it appropriately. Maybe keep the super sensitive stuff internal if possible, or give it the highest protection in the cloud. 6. Encrypt all sensitive data. Seriously, this is non-negotiable. Encryption at rest, encryption in transit. It's shocking that 60% of businesses still don't encrypt half their sensitive cloud data. Crucial for protection and compliance.
60% is staggering.
It really is. 7. Understand your SLA and legal contract. Know it inside out. Roles, responsibilities, incident response, liabilities. It needs to be clear with your CSP. This is your rulebook when things go wrong.
Got it. And finally, operational excellence, keeping it going.
Exactly. 8. Use a compliance source of truth platform. Tools like SecureFrame can be invaluable. They centralize your compliance view, even across multiple clouds. They integrate with AWS, Azure, Google Cloud, continuously scan, find issues, even suggest fixes using infrastructure as code. Automates a lot of the heavy lifting. 9. Conduct regular internal audits. Don't wait for the external auditor. Proactively look for gaps. Stay updated on regulatory changes and adjust. Be proactive, not reactive. 10. Use automation to reduce human error. Human error causes a massive number of cloud breaches, over half, according to some studies. Automated workflows. AI tools like SecureFrame's Comply AI for remediation can automatically find and guide fixes for misconfigurations, reducing manual errors. And 11. Leverage continuous monitoring. Compliance isn't a once-a-year thing. Set up automated alerts for nonconformities, security incidents. Continuous monitoring catches drift before it becomes a crisis, keeping you compliant as things change.
Those 11 practices provide a really solid framework. But now, let's shift gears. What happens when you layer truly cutting-edge stuff like sophisticated AI agents onto this already complex cloud environment? The stakes for data, security, performance, they must go through the roof.
They absolutely do. And that brings us perfectly to the work of Raj, an expert who's been deep in the trenches building custom RAG, that's retrieval augmented generation and agent systems. He's been using models like Quinn QWQ32B for major Fortune 500 companies.
So not just theoretical AI, but real-world complex deployments.
Exactly. And what's crystal clear from his experience is that enterprise AI today is way beyond simple chatbots. We're talking highly sophisticated, domain-specific reasoning systems embedded right into core business processes. The compliance implications are huge here.
Can you give us some examples? What kind of high-stakes problems was he tackling?
Okay, picture this. A mid-sized pharmaceutical company. They have over 50,000 research papers, FDA submissions, clinical trial data going back decades, massive amounts of sensitive data. Raj built autonomous research agents for them. These agents dig through all that data to analyze drug safety, identify potential interaction risks, even generate regulatory compliance reports. And they had to understand tricky medical acronyms in contexts like knowing CAR T therapy isn't about cars.
So deep medical understanding was required.
Absolutely. Their workflows were multi-layered. Safety analysis, regulatory checks, literature reviews, clinical trial analysis, involving really complex reasoning, like figuring out drug interactions across different patient groups.
That's incredibly complex. What about other sectors, like finance?
Right. For a Singaporean bank involved in M&A due diligence, he built specialized agents. These things had to process enormous Excel files, quarterly reports, some over 50 million with embedded charts.
Handling complex financial data structures.
Exactly. They learn to spot financial risk patterns, pull key metrics from intricate models, and generate executive-level analysis reports in just 15-20 minutes. A task that used to take human analysts days. Their workflows covered risk assessment, credit analysis, market research, compliance monitoring, reasoning about things like cash flow and loan risk.
15 minutes versus days. That's transformative. What about legal?
Yep, legal too. For a law firm specializing in regulatory compliance, agents were processing thousands of case files, legal precedents, regulatory docs. They learned to find relevant precedents, analyze how new regulations impacted existing rules, and flag potential compliance gaps automatically.
Automating really complex legal analysis.
Precisely. And one more. An enterprise security company. They used similar agents to process internal security reports and external threat intelligence, setting the stage for automated threat analysis, incident response support, compliance monitoring, and ongoing risk assessment.
So these aren't just language models answering questions. They're intricate reasoning systems deeply woven into sensitive business operations.
That's the key takeaway. Each one required totally custom AI workflows, custom agent architectures. It wasn't just search or summary. It was multi-step reasoning, synthesizing evidence from diverse, often proprietary sources, applying specific analytical patterns to solve complex, real-world business problems. This is AI becoming truly integral.
Given the power models available now, why QWQ32B specifically? Why not something more widely known, maybe like GPT-4o? What drove that choice for these serious enterprise scenarios?
Raj found there were several non-negotiable factors that pointed directly to Quinn, deployed locally, as really the only viable path for these kinds of projects. The absolute number one, data sovereignty.
Meaning keeping the data entirely in-house.
Exactly, for the pharma company. Sending sensitive drug research, FDA submission data, patient info outside their internal servers, absolutely not an option. FDA compliance, trade secrets, it had to stay put. Same for the bank. Financial data couldn't leave their infrastructure.
So cloud APIs were a non-starter from the beginning.
Immediately off the table. Local deployment was the only way to guarantee that data never left their controlled environment.
Okay, data sovereignty is paramount. What else?
The second major factor was the brutal cost reality at enterprise scale. When you're processing millions, maybe billions of tokens daily across hundreds of users, the API costs for models like GPT-4o become astronomical.
Can you give us a sense of the numbers?
Raj did the math, the banking client. During peak M&A season, they were looking at potential API bills upwards of $80,000 per month. The pharma company could easily hit $120,000 a month during drug approval pushes.
Wow. Compared to running it locally.
Running Quinn locally on their own hardware. The operational costs, mostly power, cooling, maintenance, were in the range of $42,000 to $68,000 a month. The financial savings were just undeniable, and the payback period on the initial hardware investment, typically 8 to 15 months. It made clear financial sense.
Significant savings. What about performance? Did Quinn hold up?
That was the third key factor. Performance on domain-specific tasks. And this was interesting. After they fine-tuned Quinn specifically for these domains, it actually outperformed GPT-4 on things like highly specialized medical queries.
Really? Outperformed the big names?
How? It developed a much better nuanced understanding of context. Like we mentioned, knowing AE means adverse event in a clinical trial report, not account executive. Or CAR means chimeric antigen receptor in an oncology paper. That level of specific accuracy after tuning was crucial for trust and reliability.
Okay, accuracy. Anything else driving the decision?
Yes, the fourth factor. Latency consistency. Local deployment meant no unpredictable API rate limits, no network lag affecting response times, no cloud outages disrupting critical work. The bank, for instance, needed sub-2-second responses consistently, even with over 115 people using it at once during deal time. Local deployment gave them that predictable, low-latency performance.
So, data control, cost, tailored performance, and reliability. That makes a strong case for local deployment in these scenarios. But what about the management side? Isn't running those big GPU clusters in-house a huge headache compared to just using a cloud service?
That's a fair question, and yes, there's definitely an operational overhead. You need the expertise to manage the hardware, the cooling, the power, the specialized software stack. It's not trivial. But the teams Raj worked with found the benefits, that absolute control over data, the predictable low latency, the massive cost savings at scale. These heavily outweighed the internal management burden. It shifted the complexity from dealing with external, unpredictable APIs to managing internal, controllable infrastructure. They viewed it as investing in a core capability, not just an IT cost center.
Okay, that makes sense. So, to deliver this kind of power, what kind of hardware are we actually talking about? These must have been some serious GPU clusters.
Oh yeah, these were substantial setups, not just one or two GPUs under a desk. For the pharma company, think a cluster of around 12 high-end H100 GPUs with 80 gigabits of VRAM each. This supported over 65 concurrent AI operations for their 150-plus researchers. The banking client, with even heavier M&A workloads, they use an even larger cluster, maybe around 15 of the even more powerful H200 GPUs, each with 141 GB of VRAM. That powered over 115 concurrent operations, scaling up to support nearly 300 users during peak times, running multiple specialized models.
Wow, H200s. And the others?
The law firm used about 6 H100s for their 45-plus concurrent operations and 100-plus lawyers. The enterprise security company, needing 247 analysis, had the biggest setup, around 16 H100s, handling over 95 concurrent ops for 200-plus analysts. All these systems had sophisticated queuing to manage the load.
That's immense computing power. And managing memory for models processing huge documents like 80,000 tokens of context must have been a nightmare. How did they tackle that?
Memory was absolutely a critical challenge. Fitting these huge models and their large context windows onto the GPUs was tough. The key technique Raj's teams used was 4-bit quantization, specifically Q4KOM.
Quantization, it's like compressing the model, right? Does it hurt accuracy?
Exactly. It compresses the model representation. And remarkably, they found it resulted in a massive memory savings, reducing the VRAM needed from maybe 65 GB down to around 18 GB per model instance, with only a minimal accuracy drop, typically less than 3%.
60% memory saving for a tiny accuracy hit? That's a huge win.
A massive win. It made fitting these models onto the hardware feasible and maximized how many concurrent users they could support. They also used smart context management. Not every query needs the full 80K tokens, so they dynamically allocated context based on the task, maybe 20% of slots for long analysis, 50% for medium queries, 30% for quick ones, plus enterprise-grade load management, priority queues for urgent stuff, batch processing for less critical tasks, smart scheduling, and for the multi-machine clusters, high-speed InfiniBand networking, model parallelism, load balancing, distributed caches. All the advanced techniques were needed.
That's some serious engineering. Let's talk fine-tuning.
Yeah.
How do they actually teach these models to understand complex pharma regulations or financial models? Sounds like it could take forever.
The approach was surprisingly focused. Instead of just feeding it endless Q&A pairs, Raj trained the agents on reasoning processes.
Reasoning processes, what does that mean?
For the pharma agents, the training data showed how to analyze safety across multiple trials by combining different data types, or how to structure a regulatory submission by synthesizing clinical results and FDA guidelines. For the bank, it was how to perform multi-factor risk analysis or how to systematically check M&A targets against a list of red flags.
So teaching it how to think like an expert in that field, not just memorize facts.
Precisely. The quality of demonstrating those reasoning steps was more important than just sheer volume of data, and they found that just 2 or 3 training epochs often hit the sweet spot for performance.
Clever. But surely they ran into problems. You mentioned HEL earlier.
Yeah.
What kind of struggles did they face?
Oh, definitely. Medical acronym HEL was a big one. The models initially got confused as AE, adverse event, or account executive. The workaround involved smart pre-processing to expand acronyms based on context, using medical databases like MaySH and adding specific context detectors. Then there was reasoning loophole. For really complex multi-step tasks, the models would sometimes get stuck, just repeating the same logical steps over and over without getting anywhere.
Like an AI hamster wheel?
Exactly. The fix involved implementing reasoning checkpoints, timeouts, and careful prompt engineering to force the model towards a conclusion after a certain number of steps. Agent coordination for workflows involving multiple AI agents was tricky too. Maintaining context across steps, avoiding logical errors, they built custom validation checkpoints between agent steps, used context preservation techniques, and made agents cross-reference findings against multiple sources. And finally, complex table processing in financial docs was tough. Understanding relationships between different tables, extracting interconnected data points. The fix involved pre-processing tables into more structured formats, embedding relationship info in metadata, and using specific prompts to guide table reasoning. Pragmatic solutions for real-world messiness.
This is incredible insight into real enterprise AI deployment. So the bottom line, what kind of actual performance did these systems deliver, and what were the biggest lessons learned from getting them into production?
The performance numbers were genuinely impressive. In reasoning accuracy, the pharma safety analysis agents achieved 94% agreement with human experts. The financial risk models hit 96% precision on identifying critical risks, and the legal compliance agents showed 91% alignment with senior lawyers' assessments. Really strong results.
And 90+% agreement with human experts is huge. What about speed and reliability?
Speed at scale was great too. Average query response under 2 seconds, even with 65 to 115 concurrent operations. Complex analysis that took days manually, done in 15-20 minutes. And system reliability was stellar, 99.9% uptime over 6 months, 0 data breaches reported, and a 96% success rate for automated agent workflows. The domain-specific accuracy after fine-tuning also saw massive jumps, like medical term understanding going from 73% to 94%.
Okay, those are compelling numbers. So what are the key takeaways? If someone listening is thinking about this kind of project, what did Raj learn that's crucial?
Several critical lessons emerged. First, hardware needs might be more reasonable than you think. Yes, they built big clusters, but Raj emphasized that a single high-end GPU can actually handle serious enterprise workloads now. Local AI is becoming more accessible. Second, the ROI on fine-tuning is massive for specific domains. Just a couple of weeks focused on training for medical or financial language saved months of frustration and yielded huge performance gains. It pays off exponentially. Third, local deployment solves so many headaches. No API limits, no network dependencies causing outages, no unpredictable latency, and compliance teams. They love having the data fully controlled internally.
Makes sense. What else?
Fourth, quantization is basically a free win. That 60% memory saving for less than 3% accuracy loss, essential for making deployments practical, especially on fewer GPUs. Fifth, smart context management beats raw context size. How you manage and prune the context window is often more important for effective reasoning than just having the biggest possible window. Intelligent use matters more than brute size. And finally, maybe most importantly for enterprise, reliability trumps benchmarks. Clients care less about topping leaderboards and more about consistent, dependable performance during critical business hours, absolute data sovereignty, and zero downtime. That, plus the cost savings justifying the hardware investment in under 15 months, makes the case for these custom local AI solutions really strong.
Wow. What an incredible journey from the strict rules of cloud compliance frameworks to the bleeding edge of real-world enterprise AI deployment. We've really seen how these two worlds intersect, haven't we?
Absolutely. The need for robust security and compliance only gets amplified when you introduce AI that touches sensitive data and core processes.
It really highlights that the future for enterprise seems to hinge on striking that very delicate balance, pushing innovation forward with things like AI, while maintaining rock-solid security and unwavering accountability through compliance. So here's a thought to leave you with. As technology like AI continues to accelerate and blur the lines around data, what new compliance frameworks or adaptations might become necessary? How will regulation keep pace with innovation while still enabling it? Something to ponder. And as you consider managing these complex challenges securing data, enabling innovation, remember that practical solutions are constantly evolving. For instance, Stonefly offers a really compelling solution tailored for modern enterprise security needs. Their 100 TB immutable and air-gapped SSO currently available for just $8,995.
That combination of immutability, air gapping, and single sign-on sounds like it hits a lot of the security best practices we discussed.
Exactly. It's designed to provide that robust, secure storage foundation, protecting sensitive data from ransomware and other evolving threats, while simplifying management. Definitely worth checking out if data protection is top of mind. Thank you so much for joining us on this deep dive today. We hope you found this exploration of cloud compliance and enterprise AI both informative and insightful. We'll be back soon with another deep dive into the complex world around us.